This video is brought to you by mywayteaching.com.
Universal law of gravitation. This is one of the important law which is said by Newton. Legend has it that observing an apple falling from a tree, Newton was inspired to arrive at an universal law of gravitation that led to an explanation of terrestrial gravitation as well as Kepler laws. Okay, Newton's reasoning was that the moon revolving in an orbit of radius rm was subject to a centripetal acceleration due to Earth's gravity of magnitude. Moon is revolving in an orbit. The radius of the orbit is rm, and this moon is subjected to a centripetal acceleration due to the Earth's gravitational force, or due to the Earth's gravity of magnitude, that is given by am is equal to v square by rm. In other words, we can write it as 4 pi square rm by t square, where v is the speed of the moon, which is this is speed of the moon, and it is related to the time period t by the relation 2 pi rm by t. Okay, the time period t is about 27.3 days. Okay, and rm is okay, we already known then to be about 3.84 into 10 raised to 8 meter. If we substitute these numbers in this equation 1, we get a value of am much smaller than the value of acceleration due to gravity, that is g, on the surface of the earth, arising also due to earth's gravitational attraction. Okay, this clearly shows that force due to earth's gravity decreases with distance. If one assumes that the gravitational force due to the earth decreases in proportional to the inverse square of the distance from the center of the earth, which means as we move away from the center of the earth, okay, it will decrease, and it is inversely proportional to the square of the distance. Okay, we can write am is inversely proportional to 1 by rm square, and in case of earth gravitation acceleration due to gravity, we can write like this. Okay, and we get g by am is equal to rm square by re square, that is given by 3600. So in agreement with the value of g, that is taken as 9.8 meter per second square, isn't it? And the value of am, we have taken it from the previous equation that we derived. That is given by am is equal to 4 pi square rm by t square. Okay. These observations led Newton to propose the universal law of gravitation. Then, what is this universal law of gravitation? See, every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. You just consider any two bodies. If I consider two bodies like this, the mass of this first body is m1 and the mass of this second body is m2, and they'll attract each other. Every body in the universe attracts every other body, so they attract each other. And that force of attraction is nothing but the gravitational force. Okay, we can that force of attraction is directly proportional to the masses of the two bodies and inversely proportional to the square of the distance between them. So when we convert this proportionality into equality, we get a constant. That constant is called as gravitational constant, that is represented by G. So G m1 m2 by r square. So we can represent this equation in vector form also. So that is given by F is equal to G m1 m2 minus r cap divided by r square. So that can be written as minus G m1 m2 by r square. Okay. Where G is the universal gravitational constant and r cap is the unit vector from m1 to m2. Okay, in this particular equation, G is the universal gravitational constant, as I told you before. And this r cap is a unit vector from m1 to m2. And r is given by r2 minus r1. You can see that in the figure. So here r is given by r2 minus r1. This is a gravitational force on m1 due to m2 is along r, where the vector r is r2 minus r1. See, the gravitational force is attractive. The force F is along minus r. The force on point mass m1 due to m2 is of course minus F. The force on this m1 due to m2 is minus F. By Newton's third law, the gravitational force F12 on body 1 due to body 2 and F21, that is F12 is on body 1 due to body 2 and F21 is on body 2 by body 1. these two forces are related as? Yes, F12 is equal to minus of F21, isn't it? Yes. See, if we have a collection of point masses, the force on any one of them is the vector sum of the gravitational force exerted by the other point masses. Okay, you can see that in the next figure. See, the gravitational force on point mass m1 is the vector sum of the gravitational forces which is exerted by m2, m3 and m4. So here the gravitational force on m1 is the vector summation of the forces which is exerted by m2, m3 as well as m4. Okay. So the total force on m1, we can write the total force, the total force on m1 which is exerted due to the other point masses, that is m2, m3, m4, is given by the equation, that is F1 is equal to G, the gravitational constant. First we'll consider the force exerted on m1 due to m2. So that is given by G m2 m1 by r square 21. So the unit vector r21. And now we'll consider m3, that is given by G m3 m1 unit vector r31 divided by r31 square. Okay. Now we'll consider m4, the force exerted on the m1 by m4 is given by G m4 m1 divided by r square 41 and the unit vector r4 1. So this is the total force on m1. So it is the vector sum of the gravitational forces exerted by m2 which is given by G m2 m1 by r21 square and by m3, that is G m3 m1 r31 square, and by m4 that is given by G m4 m1 r square 41. Okay.